For the next types of problems, we're going to be looking at simplifying a power of I. I to the what power? How could we get that simplified as best we can? Now, we already know that I to the first, and that does mean square root of -1, but I to the first is I, and I squared is -1. That has already been defined. Now, using some rules for exponents, we can then tackle higher powers of I. For example, I cubed can be broken down into I squared plus I to the first. That is just using our product rule for exponents. When you have the same base, those exponents must add together, in this case to give us 3. Remember, I squared is -1. And when we take -1 times this factor of I that's remaining, that gives us -I. What that means is that anytime you see I cubed, you're going to write -I. Commit that to memory. For I to the fourth, there's a couple different ways you could break that down, but the best way I think to break I to the fourth down is to write it as I squared times I squared. So essentially, we have -1 times -1, and -1 times -1 is +1. So now we know I to the fourth is +1. For higher powers of I, such as I to the fifth, we're going to break that down into, there's different ways you could do this, but the way we're going to is say I to the fourth times I. Because we just found right up here that I to the fourth is 1. If I to the fourth is 1, we have 1 times I, that will be I. So anytime you see I to the fifth, that's I. I to the sixth, we're going to break that down into I to the fourth, because we love that. I to the fourth is just +1. We're going to write it as I to the fourth times I squared. So we have +1 for I to the fourth times -1 for the I squared, and 1 times -1 is -1. And so forth. I to the seventh is broken down into I to the fourth, and I would just go ahead and say it's going to be I to the fourth times I cubed, because we know I to the fourth is 1, and we already discussed up here that I cubed is -I. So that's how they get I to the seventh is -I. For I to the eighth, we're going to break that down into I to the fourth times I to the fourth, also known as 1 times 1, 1. And then the patterns are going to start repeating. So what you really need to do is you really need to commit to memory these first 4. Anytime you see I, well, that's I, okay? Not a lot to do there. Anytime you see I squared, that's going to be a -1. Anytime you see I cubed, no, that is -I. And I to the fourth is a +1. And then the pattern repeats. We're going to talk about how to deal with that pattern a little bit later on here. So a couple of things to notice about this pattern is that even powers of I either result like I squared, I to the fourth, I to the sixth, I to the eighth. Those either result in a 1 or a -1 when simplified. When the exponent is a multiple of 4, I to the fourth, I to the eighth, I to the 12th, I to the 16th, to the 20th, to the 24th. If it's I to any multiple of 4, then it's going to simplify to be 1. So I to the 404th, that's a multiple of 4, that would simplify to be 1. If the exponent is even but not a multiple of 4, then that defaults to -1. So again, as we were discussing, that the fourth powers of I simplify to be 1. For other powers of I, we kind of need to break those down And it sure is nice when we break those down to let one of the factors be I to the 4th, or I to the 8th, I to the 12th, I to the, something that will be 1. Let's do some examples. For I to the 32nd, 32 is actually divisible by 4, right? 4 will go into 32 8 times. So since 32 is a multiple of 4, I to the 32nd power is just positive 1. I to the 47th on part B, 47 is not a multiple of 4. And so what we're going to do is use our rules for exponents to break this down into I to the 44th times I to the 3rd. Now the reason I did it this way is so that this first term, I to the 44th, is just 1. And then I cubed, remember from the box above, I cubed is negative I. And 1 times negative I is just negative I. That is where I to the 47th would fall in the pattern. I to the 66th. Now, it said, is 66, that's an even number. So the answer is going to be 1 or negative 1. Well, 66 is not a multiple of 4 because when we take 4 into 66, let's see, it'll go 16 times. 16 times 4 is 64. We have a remainder of 2 here. So 66 is not a multiple of 4. So this should simplify to be negative 1 instead of positive 1. Now another way I like to do this is if I have I to the 66th, again I like to break that down into something that's going to be 1, I to the 64th, and then we have left over 2, so that 64 and 2 add together to give us 66. I to the 64th is 1, because 64 is a multiple of 4. I squared is negative 1, so that's another way to get our answer of negative 1. For I to the negative 27th, for these, negative 27 is not a multiple of 4. So what we can do here is we can break it down into I to the negative 28, and then left over we have I to the positive 1st. Now, the question arises, is I to a negative multiple of 4 also going to be 1? Okay, so if I have I to the negative 28, we know that using our rules for exponents, that's the same thing as 1 over I to the positive 28. So this is 1 over, now I to the 28th is 1, and 1 over 1 is 1. So the lesson to be learned from that discussion is that if the exponent is a positive or a negative multiple of 4, it simplifies to be 1. So back over here on our example 42D, I to the negative 28 is 1. Then we have times I. 1 times I is I. That's how that one would simplify. Now, the tip in the green box says that if you want to simplify I to some power, you can divide the exponent by 4, then use the remainder to figure out what power of I you have left over. So, for example, if you had I to the 50th, take 50 divided by 4. 4 will go into 50 12 times. 12 times 4 is 48. When you subtract to find the remainder, it's 2. And so now what you need to do is you know that I to the 50th is going to be the same thing as I to the remainder of 2, and I squared is negative 1. And that's what we would get here as well. So you might want to do that division to simplify those types of problems.